Let's look at this new question now. It says show that the function f defined from set of real numbers to the set of real numbers defined by f of x is equal to x by x square plus 1, where the domain is set of all real numbers and the range is the set of all real numbers. We need to prove that this is neither 1 1 nor onto. So we are trying to prove that the given function is neither 1 1, it's not 1 1. So we look for a counterexample, and not onto. Again, we look for a counterexample. So to look for a counterexample, it's not that simple. You need to know how does it work. It's going to be like f of 2 I work out, and then if I work out f of 1 by 2, it's going to give me the same answer. Or maybe if you try 3, f of 3 and f of 1 by 3 is going to give me the same answer. If you really analyze this function, you will understand it. F of x and f of 1 by x are actually the same. So this is definitely not going to be 1 1, it's going to be many to 1. But I give a counterexample. I do f of 2 first, and then I'll work out what is f of 1 by 2. F of 1 by 2 means wherever x comes, I replace it by 1 by 2. So I have 1 by 2 in the numerator. Denominator is 1 by 2 square, which is 1 by 4 plus 1. I take LCM of 1 by 4 and 1, which is going to be 5 by 4 there. I took LCM. And now to divide by a fraction by another fraction, I multiply with its reciprocal, which will give me 2 by 5 again. And that's when I realize, okay, my f of 2 is 2 by 5, and f of 1 by 2 is also 2 by 5. Two distinct elements, 2 and 1 by 2, but they have the same images. F of 2 is equal to f of 1 by 2, and therefore f is not 1 to 1. Next part is to prove that it is onto. So what we do for this is, I'm trying to figure out a counterexample for this as well. So I'm going to choose a value y is equal to 1 by root 2, which means I picked up a value from my codomain. And my aim is to show that there is no x in the domain which will make this 1 by root 2 as my f of x. So to start with, we'll say let f of x be equal to 1 by root 2 for some x. So which means I'm trying to say that there is an x which will give me 1 by root 2 as its image. So I'm trying to say that the element 1 by root 2, which I picked up from the codomain, has a pre-image x in its domain. Let's try to work it out. So x by x square plus 1 is my f of x. So I write x by x square plus 1 is equal to 1 by root 2. This I can cross multiply both the ways. And so this is what I get when I cross multiply. I rearrange it like a quadratic, bringing it to the left side. So this is what I have with a is equal to 1, b is equal to minus root 2, and c is equal to 1. It's a quadratic, so I list out the values of a, b, and c so that I can apply quadratic formula to solve this quadratic equation. And the quadratic formula is x is equal to minus b. Of course, I didn't write the formula, minus b plus or minus root of b squared minus 4ac. Sub in the values, minus b minus of minus root 2, which is 1 by root 2, plus or minus root of b squared. B squared is 2 minus 4ac, 4 into 1 into 1 divided by 2a, 2 into 1. And this is going to work out to be an imaginary number. So which means this does not belong to the set of real numbers. So that means I don't have an x which will make f of x is equal to 1 by root 2. I write f of x is not equal to 1 by root 2 for any real number x, because the value of x which I got is not a real number, it's a complex number. So there is no real number which will give me f of x is equal to 1 by root 2. Therefore f is not onto, because your 1 by root 2 does not have a pre-image. That's what we proved. It's a counterexample, and so this is not onto. But of course, now we finished that, and then we have one more part of the question to find out f of g of x, which means it's f of g of x. I'm not doing it. You may complete that yourself. F of g of x. F of 2x minus 1. So this 2x minus 1 should go inside your f of x. So x will be replaced by 2x minus 1. So this is going to be 2x minus 1 divided by 2x minus 1 the whole square plus 1.